Hi, I'm Jeff Wilson, and this talk is about three fundamental problems with generative AI. Generally, the term AI is regarded as referring to artificial intelligence, but in the phrase generative AI, that definition seems inappropriate, and a more accurate rendering is surely approximating interfaces, for the simple reason that such systems lack both precision and intelligence. The critical weakness of a generative AI system is a lack of any innate intelligence, and it only takes a moment's reflection to find a simple example of this, as such systems have no curiosity and also lack any cognitive model for what they could be curious about. Obviously, code bandages can be applied to any computer system, and so one must take great care that any testing proofs have not been tweaked. Also, as I've written elsewhere, multiple choice questions are not a reliable way to test an AI system. Let me now consider three fundamental problems with generative AI systems that prevent them ever achieving AGI, artificial general intelligence, in the everyday meaning of that term. Firstly, generative AI systems will always hallucinate. There are three reasons for this. Firstly, because training data is always corrupted to some extent. Secondly, because the vectors used are always approximations. Thirdly, because hyperspheres are very, very spiky, so no precision. Secondly, the lack of cognitive representations for tokens. The vector representations used are not based on cognitive concepts. As an example of this, they have no explicit gender vector. Instead, the concept of gender is smeared, and this imprecision again blocks any path to AGI. Thirdly, the lack of any standardized representation for documents. From screw threads, shipping containers through to the World Wide Web, wealth creation requires precision and standardization. Currently, generative AI systems only approximately encode documents into a cognitive form, and also the encoding is proprietary with different vector representations and different encodings of cognitive concepts, a further block to AGI. These three problems perhaps explain why currently there is so much focus on text to images, where approximations are good enough. In contrast, intelligence requires precision and a standardized representation of cognitive concepts.